State the oxidation number for each element in each of the following compounds. A, SO3 2 minus. B, Fe2O3. C, N2. D, NaCl. E, H2O. F, SiO2. So a couple of quick tips to begin with. Whenever oxygen is in a compound or a molecule, unless it's by itself like O2, it's going to have an oxidation state of -2. That's almost always true. There's only a couple of exceptions to that, so you can use that as a guide. The other thing is that hydrogen, when it's combined with something else, is almost always +1, so you can also use that as a guide to figuring out the other things. The other tip is you should look in the corner of each element here to see what's there. If there's nothing there, it means 0, and if there's something there, like in example A, that's what you have to have everything add up to. So in the case of A, it should all the oxidation states, when combined with how many elements you have, should add up to -2. For the rest of these examples, they should all add up to 0. So let's start. We'll use O2 to start here, or O to start, sorry, and it's -2. And we have 3 of them, so that's a total of -6. Now, I want to be clear here that what's written in red, the -2, is the oxidation state. It's not the -6. The -6 is just to help us figure out what sulfur's oxidation state is. So the red numbers will be the actual oxidation states. The blue numbers are just to help us. So we also know when we look at these blue numbers that they should add up to -2, since that's what's in the corner here. So if you think about what -6 is -2, you'd have to pick +4 here as what's going to have to relate to the sulfur. You only have the one sulfur, and so sulfur's oxidation state then must be +4 for everything to add up to -2. Do the same thing with B here. Oxygen -2. Again, we have 3 of them, and so that's a total of -6. Only this time, because there's nothing in the corner, everything has to add up to 0. And so what -6 is 0? Well, +6 -6 is 0. But you have 2 irons this time, instead of just 1, like in the previous example. And so the oxidation state of iron must be +3, since +3 times 2 adds up to +6. Nitrogen by itself, anything by itself, no matter what the element is, whether it's a diatomic or if it's just something like potassium where it's just K by itself, anything by itself is 0. Oxidation states sort of track where the electrons are, and there's no reason why either of the 2 nitrogens would have the electrons more than the other, and so we just say 0. There's neither one of the nitrogens holds them more than the other. In the case of the previous example, what the -2 tells us is that each of those oxygens is controlling or is taken, in the case of ionic compounds, 2 electrons, and that the oxygen, or the irons in the case of example 2, have lost 3 electrons. So that would be iron 3 oxide if you think about the naming too. So the Roman numeral in the type 2 ionic compound naming is actually the oxidation state. D, there's neither oxygen nor hydrogen, or nothing to base this around, and so what we need to look at is this is an ionic compound, and ionic compounds take the oxidation state, same number of electrons lost or gained. So when you look on the periodic table, you know that chlorine accepts 1 electron and sodium gives 1 away, and so hence the oxidation state of chlorine will be -1, and the oxidation state of sodium will be +1. H2O, well, we can follow just our general rule here. That's one that almost always works, is that oxygen will be -2 and hydrogen will be +1. And if you go through the, that should add up to 0 since there's 2 hydrogens and just 1 oxygen. Lastly, again, we'll look at oxygen and say it's -2. In this case, we have 2 of them, and so that's a total of -4. This whole thing has to add up to 0. And so that means the silicon has a +4 associated with it. Since there's just the 1, the oxidation state of silicon must be +4.